Lesson 4.6, surface area. So we've looked a little bit at the area of 2D shapes. Now we're going to look at the surface area of 3D shapes. So the surface area of an object is the area of all faces of the object combined. Think of it as how much paint you would need to cover a 3D object or a 3D space. So for example, if we're thinking of a 3D object like a box or a can or something like that, you're thinking about painting the outside. But you might also think about a space. So for example, if you're thinking about painting a bedroom and you're thinking about all the walls, that would be surface area as well. To find the surface area, we can use something called a net, which is a drawing of what the shape would look like if it were flattened out. This allows us to see all the faces at one time. So if we were to take a 3D shape and flatten it out or lay it out flat, that's what we call a net. So we're going to start by looking at rectangular prisms. A rectangular prism is a 3D shape whose sides are all rectangles. We often call a rectangular prism boxes. So if you think of a box, that is a rectangular prism. To find the surface area of a rectangular prism, we take the area of all 6 sides. So the front, the back, the right, the left, and the top and bottom 6 sides by multiplying the length times width each time because they're all rectangles. So for example, if we wanted to find the surface area of this cube, so it's a cube, which means we know that all the sides are 3 inches long. So in this example, the solid shape is a cube and each face is a square measuring 3 by 3. So the length is 3 and the width is 3. So if we were to draw the net of this shape, it would look something like this, where you have all 6 sides laid out. And if you were to think of a box, if you'd cut it open so it would lay flat, that's what it would look like. You have the top and the bottom, at the top and the bottom of the 2D image, and the front and the back and the 2 sides being stretched out into 4 squares. So because it's a cube, we know the length and width of each one of these squares is 3. So to find the surface area, first we find the area of each face, and then we add all of those areas together. So remember, area of a rectangle is just length times width. So the first face would be 3 by 3, which is 9. 3 by 3, which is 9. 3 by 3, which is 9. Because remember, the length and width of a cube is always going to be 3 by 3. 3 by 3, 9, 9, and 9. So a cube is made up of 6 faces, and each face has an area of 9. So the surface area would just be 9 plus 9 plus 9 plus 9 plus 9 plus 9, which is 54 inches squared. So the units for surface area are the same as units for area, which is just whatever our measurement is in this case inches squared. All right, so you don't have to draw the net as one big piece like we just did, but instead, if you wanted to, you could consider each side separately or in pairs, because we know that the top and bottom are going to be the same size, the front and back are going to be the same size, and the right and left are going to be the same size. So if you think of them in pairs, you don't have to draw one big shape because sometimes that can get confusing. So for example, if we wanted to find the surface area of the following rectangular prism. So it has a base of 3 by 2 and a height of 6. So the top and bottom, which are a pair, they're the same size, are a width of 3 and a length of 2. The right and left, which are the 2 sides, would have a length of 2 and a width of 6. And the front and the back, which would be the same size, have a width of 3 and a length of 6. So I didn't go and draw all 6 sides exactly as it would look spread out. I just considered each pair of sides. So I considered the top and bottom and drew that as its own rectangle, the right and the left and drew that as its own rectangle, and the front and the back and drew that as its own rectangle. Then I can find the area of each rectangle and I would double it because, for example, if I found the area of the 3 by 2 rectangle, which would be the top, I also have to include the bottom, so I'd have to double it. So let's look. So we would do length times width. to find the area of the top or bottom, which would be 3 by 2 or 6. Now to find the area of the right or left side, we have that same width of 2, but we're going to call that 6 measurement the height because it's the height of a rectangular prism. So we're doing the height of the prism times the width of the prism, which would be 6 by 2 or 12. And finally the front and back, so we're going to call that 3 the length of the rectangular prism and 6 is still the height. So we're going to do the length times the height, which is 3 by 6 or 18. So now that we have the area of each piece, we did the top and bottom, the right and left, and the front and back, we know that the surface area is the area of the top plus the area of the bottom, plus the area of the right plus the area of the left, plus the area of the front plus the area of the back. But we know all those measurements. So it would be 6 plus 6 for top and bottom, plus 12 plus 12 for right and left, plus 18 plus 18 for front and back, for a total of 72 squared centimeters. Notice that when we completed the calculations in the example, to find the area of the top and bottom, we multiplied length by width, and then we doubled it for top and bottom. To find the area of the right and left sides, we multiplied width by height, and we doubled it because it's left and right. And to find the area of the front and back, we multiplied the length by height, and we doubled it because there was the front and back. So we can use this information to help write a formula for area of a rectangular prism that looks like this. The surface area is 2 times the length times the width, plus 2 times the width times the height, plus 2 times the length times the height. So I will give you that formula on any tests and assignments, and if you prefer to just use that, that's fine. Or if you prefer to draw out the nets, if it makes a little more sense, that's fine as well. Okay. Look at cylinders. So a cylinder is a 3D shape made of a rectangle wrapped around 2 circles. We often call cylinders can-shaped. To find the surface area of a cylinder, we find the area of the top and bottom circles, and we unroll the rectangular body of the cylinder to find its area. So I'm going to show you a quick video just so you can see what the net of a cylinder looks like. So we have a cylinder here, and then it's going to be unrolled or unraveled, and you can see what it looks like. So you can see when you unfold it, that body, that middle part, unrolls into a rectangle. And the length of that rectangle, that long edge, goes perfectly around the outer edge of the circle. And if you remember when we did the last section on perimeter, we talked about that the perimeter has a special name when we're talking about a circle, and that's the circumference. So knowing this will help you find the dimensions of that rectangle that makes up the body. So the length of the rectangle is just the height of the cylinder, how tall the cylinder is. And the width of the rectangle is the circumference of that circle, because remember that edge of the rectangle wrapped all the way around the circle. And how do we find circumference of a circle? 2 times pi times r. Let's see an example. Find the surface area of the following cylinder. So the cylinder has a height of 3 and a radius of 4. So we're going to start by drawing the net and then finding the proper dimensions of the rectangle. So there's our net, there's our 2 circles, our top and bottom, and there's the rectangle that makes up the body. So remember that long edge of the rectangle is going to wrap perfectly around that circle. So to find the length of that long edge, we just find the distance around the outside of the circle, which is circumference. So we're going to find the dimensions of the rectangle by finding the circumference of the circle, which is 2 times pi times r. So we do 2 times pi, which is 3.14, times the radius, which is 4. And the circumference of the circle, which would be the length of that rectangle, is 25.12. So we'll fill it in right there. So once we have the dimensions of the rectangle, we can go and find the area of the circle, and we're going to end up doubling that because there's 2 circles, and the area of the rectangle. by length times width. So we know that area of a circle is pi r squared. These are all equations that you will have on a formula sheet. So area of a circle is pi r squared. So we do 3.14, which is pi, times 4 squared. Remember, we always square the number first. So 3.14 times 16, which is 50.24. So the area of the circle is 50.24. Now we're eventually going to double that because it's two circles. So the rectangle, area of a rectangle is just length times width, but in this case our length is the height of the rectangle and our width is the circumference. So you could say h times c if you wanted. And our height is 3. Our circumference is 25.12. We found that in the last section. So our area is 75.36. So to find the surface area, we do the bottom, which was 50.24, plus the top, which is also 50.24, plus that rectangle in the middle, which was 75.36. So our total surface area would be 175.85 millimeters squared. Now luckily, as long as you understand where all that came from, we are able to come up with a formula that you will again be given on a formula sheet. So notice when we completed the calculations in the above example, to find the area of the top and bottom, we used area equals pi r squared and we doubled it. To find the length of the rectangle, we used circumference equals 2 pi r. And to find the area of a rectangle, we multiplied the length, which is that circumference, times the height of the cylinder. So we can use this information to help us write a formula for the area of a cylinder that looks like this. So the surface area is 2 pi r squared, which is 2 times the area of the circle, plus 2 pi r, which is the circumference, times h, which is the height. So that first little bit, 2 pi r squared, represents the area of both circles. And that second little bit, 2 pi r times h, represents the area of the rectangle. So I will always give you this equation. If you just like to use this equation instead of having to do all the pieces separately, that's fine. But if you feel comfortable just using the net, that's fine too. The tricky thing about this equation is making sure you do it properly using proper order of operations. So we're going to try this example where we're going to use the formula for surface area of a cylinder to find the surface area of the following shape. So it has a height of 5 and a radius of 7. So there's our equation where it's 2 pi r squared, which is the equation for the area of the two circles. So 2 times pi r squared, which is the area of the circle, plus 2 pi r h, which is the circumference of the circle, times the height of the circle, h. So first we're going to fill in all the numbers we know. So we know r, which is the radius, is 7, and h, which is the height, is 5. We can also fill in 3.14 for pi. So we get 2 times 3.14 times 7 squared, plus 2 times 3.14 times 7 times 5. So what's really important here is that you divide this equation up into two pieces. The first one is before the plus sign, so 2 times 3.14 times 7 squared. And the second one is after the plus sign, 2 times 3.14 times 7 times 5. Because those two sides of the equation have to be dealt with completely before we're allowed to add, because our order of operations tell us that adding goes last. Okay? So if we look at the left side of the equation, the first thing we're going to do is square that 7, because we always square our numbers first. So it looks like 2 times 3.14 times 7 squared, which is 49. And on the other side, I just got rid of the brackets because we really don't need them. But we're still keeping our equation in two separate pieces. So before the plus sign and after the plus sign. So then if I multiply those pieces out, so 2 times 3.14 times 49 is 307.72. The other side, 2 times 3.14 times 7 times 5 is 219.8. Now I've gotten them as simplified as possible. Now I'm allowed to add them, and the surface area of the cylinder is 527.52. See, the important thing about using this equation, if you're going to use the equation, is to separate your equation into the left side and the right side and simplify them as far as possible before you add. Because if you add too early, you're not going to get the correct answer. So that's the end of our lesson 4.6. It is kind of a complex one. So if you have any questions or anything you weren't really sure about, make sure you ask and give the lesson 4.6 worksheet a try. And then we'll go through it as a group because it is kind of a complex topic.